To use the lithium battery safely, you must use the lithium battery BMS. Today we'll make a precise lithium battery BMS. Let's make an LiFePO4 16-string 40 amps hardware BMS. And now we've designed is a 16-string battery pack. We need to do simulation tests. This step is the drawing board, which is how to make a circuit diagram stand out on the circuit board. That is, the layout of the PCB circuit board. The next step is to play the board sample. This work is handed over to the board factory. They got this board ready. This is well-known PCB board. You can put this board on the automatic production line. The direction must be correct to ensure that there's no dust on it. Next, we put the solder paste on the PCB. The next step is to paste the PCB board. There are two automatic placement machines here. They are responsible for different materials. If there is a corrected sticker after it's passed, it will be automatically calibrated here and will be corrected by the coordinates. Next is reflow soldering. In fact, it's equivalent to a large oven. It is responsible for melting the solder paste and soldering components to the PCB board. Next is machine test. Find out the bad patch above, that is AOI detection. This is an instrument similar to the magnifying glass. Let's check it manually. We're going to make other steps to finish all the parts. The first step is to weld a temperature control probe to the BMS to detect the temperature of the battery pack. In the second step, we are to solder the socket to this BMS. For 16 strings, choose a 17-pin socket. No soldering can be missed, no tin can be connected, and the amount of the tin must be sufficient. Next, we will solder the B+ and the P+ lines to the BMS. This B line is blue, P line is black. It must not be reversed, and there are signs on the board. It's done. We're going to put a silicon sheet on this MOS tube. It's a heat-conducting medium between the heatsink and the MOS tube. This step is very critical. Install the heatsink. Inject glue for waterproof, anti-vibration, and anti-oxidation. Perfect. Now let's do a functional test on the BMS. Check whether the overcharge, over-discharge, or current and internal resistance of the BMS are normal. The test passed. For the 16-string BMS, we had to choose a 17-pin cable. Let's put it on and see if it fits. It's very tight. We'll also do an insulation test for the BMS and an actual charge and discharge test of it. And finally, we had to do the high and low temperature resistance test of the BMS. Is it easy to make BMS? The BMS is done, and which fuels can be used? Energy storage systems like LiFePO4 48 volts and a power system like LiFePO4 48 volts.